Hello everyone! Finally after 4 videos reviews on psychopathically hard 2024 season silver problems, we finally get to do a regular level 2022 silver problem today. That is the USACO 2022 February contest silver problem 1 of redistributing gifts. You can pause the video first and look at this problem yourself. Pretty short. Alright, as you read the problem. So basically, Farmer John gave n cows n gifts where n is less than 500. Just look at that tiny number there. If this was 2024, that number would be like 5,000. Anyways, each cow has a wish list. However, Farmer John did not distribute the gift according to the wish list. So cows are going to exchange gifts so that each cow either gets the same gift as she did originally or a gift that she prefers over the one she was originally assigned. And now compute the most preferable gift cow I could possibly receive after the reassignment. And all these queries are independent. So all these cows are independent. So for every cow, you compute the best they could receive without considering the others, as long as they receive either the same as original or better than original. Alright, you can pause the video once again and think about this problem yourself. Alright, this problem is actually so much easier compared to the 2024 season problems, because 2024 is just, weird. Anyways, this problem, basically, the only thing I need to observe or know for this problem is to connect edges. So, obviously, for each cow, we can only exchange gifts from this cow from the gift she originally have to a gift that's better. Sorry, I'm going to do A1, A2, A3, A4, and say she originally ended up with A4. And we have A5, A6, right? So we know that we can get gift for this. We can get A1, A2, or A3 instead of A4 after the reassignment. And we know that A1 was originally assigned to cow 1, A2 was originally assigned to cow 2, and A3 was originally assigned to cow 3. So we can connect edges here. We can connect an edge from cow 4 to cow 1 and cow 2 and cow 3, right? Because we know that we can switch from cow 1 to cow 4, or cow 2 to cow 4, or cow 3 to cow 4, because all of those are better than what cow 4 originally got, right? And that's saying if it's 1, 2, 3 that's greater than 4. If this was like 4, if this was like 5, actually, this was 6, this was 7, sorry, horrible drawing, well then this would be 5, 6, 7, right? Connecting the to 4. And after this, we will have a directed non-acyclic graph. So it's not a DAG, but I don't know if that's a thing, D and AG, but we're going to have a graph here. And how do we know if a cow can receive this gift? Well, first thing we notice is that if a cow can receive a gift, so say we have multiple edges pointing out, if this one is the most preferable, if this edge connecting to this thing is this cow's A1, most preferable gift, well then this only works if there is some kind of a loop that somehow connects back to this cow. Because only when that happens does each one of these cow is able to receive a better gift or the same as originally assigned, so that this cow can finally get this. Right? So let me mark this. This is the optimal gift that this cow that we're considering here wants, and she can only get this gift if there is a cycle that starts with this edge and end finally back on the same cow. That's the only possible situation in which we can get this cow this gift. And we're actually able to do that because if we look at it, n is only 500. So if we just, for each cow, iterate through every single gift that she wants, and then from the most preferable to the least preferable, and then for each one we check if there's a cycle, this algorithm is only actually going to be n squared. So this is my implementation. This code is so short. Like, I love this problem. Finally, a regular non-2024 styled silver problem. So first n cow. See, there's not even multiple test cases. Like, why can't 2024 season be like this? Sorry for complaining, but and then each cow, that's the gift wish list, right? And obviously, if this cow hasn't appeared yet, that means all of these gifts. This means that the gift that this cow is receiving haven't appeared yet, which means that the jth gift is better than what this cow is originally receiving. So then we connect the edge to it. And then for each cow, we check through the wish list. If this one works, by DFSing, if this one works, meaning there is a cycle, then this is the answer and we break immediately because we're iterating through from the most preferable to the least preferable. So once we see one that works, we break because that's the answer. And the DFS is also super simple. Now it's just the cal I, and if x is equal to now, that means there's a cycle, so return. And yeah, this is just standard DFS. Look at this problem. A little bit of thinking, a little bit of coding, and you're done. This is what a silver problem is supposed to be like. Not like 2024, where there's like 400 rows of code after like 25 math formulas, you solve it. This is what a silver problem should be like. Anyways, I complained a lot today, but yeah, this is a great problem for silver. It's easy. You just connect edges and then you DFS, and that's basically all. All right. Thank you so much for watching and hearing me complain about it. All right, that was a fun problem. So that was it for the problem review of today, and now it's the grind time. So the grind report, I didn't actually study as long as I would have wanted today, only 4 hours, but I did complete a mock contest, and this one is the 2019 January contest. And as you can probably tell from the name, this is really easy. And I expected it to be easy. That's why I marked the gold instead of silver. However, I was not expecting it to be that easy. I solved both of these two problems completely and both within like an hour, I think. Especially the shortcut is just so easy. It's just standard Dijkstra. If you know the Dijkstra shortest path algorithm, you can solve this problem with less than an hour, like even less time than I spent. Sleepy cow sorting, it's a tiny bit of binary index tree or segment tree. I'm stupid, so I use segment tree, but you can solve it with binary index tree. And other than that, it's basically bronze level. And poetry, cow poetry is a little bit more difficult. I was not able to completely solve in contest, but after contest, I realized my DP idea was really, really, really close. I got stuck on a tiny bit of the unbounded knapsack thing, but I was really close. So I basically could have gotten all three problems within like 3 hours for this contest. I was not expecting it to be that easy. And if you compare that to the 2024 season, this is like bronze level if you put it in the 2024 season or 2025 even. So yeah, I did not grind a lot, 4 hours, but it was a good contest. No, not a good contest. It was an easy contest. But yeah, I should probably spend a little bit more time tomorrow. Okay, hope this video helped. Thank you for watching.